Now with me here is a build which has 32 cores and 64 threads. It has the 9975WX processor, a Threadripper processor.
This video is sponsored by AMD.
The top end variant of this processor goes up to 96 cores and 192 threads. And chances are that your favorite movie, like The Terminator or even Avatar, is probably rendered on machines like this. The question really arises, what else do people use these kind of machines for? Now, before we answer that question, let's quickly, and yes, very quickly, talk about the specs of this machine. Now, Threadrippers are usually built on two platforms, TRX50 and the WX90. The TRX50 has 80 PCI lanes and quad-channel memory, that means 4 RAM sticks that can be added. The WX90 has 128 5.0 PCI lanes, plus a 8-channel memory. The one we have installed here is Gigabyte TRX50 Aero D. The GPU on this is the 9070 XT. Now for memory, Threadripper utilizes registered ECC memory. This has DDR5 registered memory. This has about 128 gigs if I'm not mistaken. And just for the record, on the WX90, you can actually go up to 2 terabytes of memory. 2 terabytes hai bro. 4 साल पहले मेरा hard drive भी नहीं था उतना. 2 terabytes. Now this isn't for the regular home user. It's for demanding tasks like 3D rendering, which require many cores to cut a 2-hour job into 30 minutes. The speed allows the team to create most versions and meet deadlines. Now buying a Threadripper may be too expensive for a lot of people, but imagine a workload where multiple people are working on a project and that needs to be rendered. Imagine that. Now imagine a game dev studio where multiple people are sitting and working on their section of the game. And then the time comes to test that nightly build. Guess how it's being compiled? Because even today, CPUs are responsible for compiling that code. Steps in Threadripper. Now a smarter plan would be to give multiple people cost-effective machines and make sure that this machine is doing your rendering only. That saves a lot of time, right? And doesn't hold up your regular machine because it's rendering the project. Now this approach is perfect for large size projects. On a skyscraper using BIM, Building Information Modeling, each person can work on their part using a standard PC. The team then assembles and renders the final one, complex model, on this powerful monster. Now CPUs are just more precise. Precision is a factor that makes this the perfect thing for a lot of use cases. Now imagine quantitative trading, where even a small mistake means you lose a lot of money. You don't want to make a 0 or decimal error mistake there, do you? Now we have built similar systems for traders like this who do algorithmic trading, and guess what they use? Guess? कोई आंसर नहीं आ रहा.
2,000 years later.
Threadripper! Now imagine a cricket match. A single broadcast server must simultaneously capture flawless, uncompressed 4K footage, at times 8K footage from multiple cams. Spider cam, stump cam, hero cam, main cam, broadcast cam. All of those cams. Each stream requires its own high bandwidth lane to avoid being bottlenecked. Then comes real-time processing pipeline. This raw data must be instantly routed from capture cards through multiple GPUs for encoding and then sent out for streaming. With 120 lanes, you create non-blocking infrastructure where every component can communicate at maximum speed. And finally, it goes without saying, a live broadcast is kind of mission critical. It can't fail. It's not supposed to, it cannot. If you ever watched an IPL match, chances are it's been streamed through a system like this, built by people like me. इस पे हमने वीडियो बनाया, you should definitely check it out. Now think of F1 races, Formula 1 that is. Max Verstappen की जय हो. Yeah, these races are won by thousandths of a second, just by thousandths of a second. You know how aerodynamics of an F1 car are fine-tuned? Enter computational fluid dynamics, CFD. Now ANSYS Fluent, which is a popular software used by a lot of F1 teams, is actually notorious for using high memory bandwidth. And guess which processor gives you high memory bandwidth? A higher core count is useless. Actually useless if your cores are starved of data. They need to be continuously fed with data so they keep doing the next thing. Because these processors are perfect for breaking down a task into multiple branches and then working on it simultaneously. Now, speaking of cars, imagine the computational nightmare of simulating a full frontal crash. Imagine that. Millions of elements representing the chassis, powertrain, and safety system must be analyzed for stress, strain, deformation in microsecond intervals. This isn't just calculation, it's a brute force problem that scales directly with processing power. Now, the entire multi-gigabyte model of the car, every bolt, weld, material property must reside in the high-speed memory. The Threadripper support for massive RAM capacity over 8 channels is absolutely critical, and it keeps all the 96 or 64 cores that you have fed with data, ensuring that they're constantly calculating. So yes, if you have that one specific workflow which needs something of this size and this power, you know who to get in touch with. We have stores across the country, and our website is www.themvp.in.